expressions. You've just mastering the topic of factoring, and while working with rational expressions in your next chapter, you're going to have to factor almost constantly. What you're going to do during this chapter, rational expressions are basically algebraic fractions, and what you're going to do is you're going to learn how to simplify fractions, multiply and divide fractions, and add and subtract fractions. Again, they're called rational expressions, but we mean algebraic fractions. Finally, you're going to learn to solve rational equations. Again, they're going to be equations that involve algebraic fractions in them. The first step in the process of working with rational expressions is to learn about values that would make the expression undefined. And so that's what we're going to look at first here. If I had the rational expression y minus 4 divided by y plus 6, all I'm looking for is a value that I might put in for y. Again, I'm just looking for a value that would make this expression undefined. And what would make this expression undefined is if we were trying to divide by 0. So without even doing any work here, if I put a value for y of a negative 6 into this expression, and I don't really care about the numerator, but I would be doing it for both. If I did that, I would have a 0 in the denominator. That makes an expression undefined. We can't divide by 0. So what you're going to do is you're going to be taking the denominators of expressions when trying to find the value for which the rational expression is undefined. And you're going to set that denominator equal to 0, and you're going to solve for the variable y. And in this case, that process is awfully easy, and I see that the number, a negative 6, in this denominator would make that equal to 0. But this is a process that you would use every time to find the value that makes the expression undefined. This expression is not quite as easy as the last one, where we could just see that the value of a negative 6 for y would not work in the expression. What I'm going to do now is I'm going to use the zero product rule, which we concluded in our last chapter, to take this denominator and set it equal to 0 and solve that for p. Look for the values for p that would make this denominator 0. So again, I use the zero product rule. In doing that, again, I'm going to set the denominator equal to 0. And we learned using the zero product rule that if I would factor, because I have 0 on the right hand side, if I would factor the left, and this is a trinomial that's got a 1 in front of the squared term. So now I'm looking for two numbers whose product is a positive 10. That add to be a negative 7. Those are going to have to be negative values for their product to be positive and for them add to be 7. They are going to have to be 5 and 2, because a negative 5 times a negative 2 is a positive 10, and a negative 5 plus a negative 2 adds to be a negative 7. Now all I do is I use the zero product rule, so I let p minus 5 equal 0, and I let p minus 2 equal 0, and then here I'm going to add 5 to both sides. And I find out that one of the values that does not work in this expression is the number 5. Here I'll add 2 to both sides, and I'm going to find out that there's another value, in this case a 2, that will not work in this expression because it will cause the denominator to be 0. Let's just check this one. I won't bother to check both. But when I put a 5 in for p, so I'm going to take 5 and square it, and I'm going to subtract 7 times 5, plus 10. Order of operations tells me to do this first. So I'll have 25. And I'm going to go ahead and multiply next. Minus 35 plus 10. And I work from left to right. I have a negative 10 plus 10. And sure enough, that value of 5 for p, when put into the denominator, does cause that to be 0. That is one of two values that will not work in this rational expression and causes it to be undefined. One last example for finding out whether or not, or what value for this rational expression will cause this expression to be undefined. Again, I'm going to take the denominator and set it equal to 0. And then the zero product rule says that I should factor this side in order to solve this equation for x. And I see that there's a common factor of 5 in this expression. I'm going to get that out. And what I do, I'm left with this x minus 6 in parentheses. The zero product rule says to take every factor and set it equal to 0. There's no point in setting 5 equal to 0 because it's not a true statement, and it does not include the variable. However, the x minus 6 will be set equal to 0, and I'll add 6 to both sides, and I'll find out that the only value that does not work in this expression, because it causes the denominator to equal 0, is the number 6. And just check this out. 5 times 6 is 30. then when you subtract 30, you get a denominator of 0, and we cannot divide by 0. That's the issue here, and you're looking for that value. This is how this chapter starts.